Go through a few case studies of what we've actually been doing, which paints a better picture of what happens at the office. So we build these robots almost from the ground up sometimes, and we send them out there to these environments, such as a ship propeller here, to take high quality data, because what we wanted to do for the client here is tell them the condition of their asset without having to bring the ship out of water, which can cost millions. So we deployed this robotic system that can go out there and collect these high definition images. But underwater, when you capture an image, you can't see very far. So the idea is now, how do we present that data to the client? And the way we do that is use computer vision algorithms to be able to stitch the information together to provide a bird's eye view of these assets to the client. The client now is able to reason about these large scale systems, which they couldn't do before, in a single click. So they're able to observe these things, take measurements there, they can observe these things all the time, and this is something they had never seen before until you take a ship out of water. You know, the conventional way was a diver would go down with a waterproof notepad and they would say, oh yeah, blade, this thing has this dent on it. Now they can track things over time and also saves them a lot by not having to depend on the ship coming out of water. Something completely different on the land scale is inspections of road tunnels. You know, just across the cross-city tunnel here is a good example where they shut down the tunnel every X or so months for a couple of nights, and they literally have people in trolleys with a flashlight looking through, especially if it's below sea level, looking for things that is there any water leaking anywhere, are there any cracks there that we need to do something about. So we worked with the right parties there to be able to deploy a camera system on a vehicle that could automatically collect data at a high density. And we collected terabytes and terabytes of data. But this is where sort of our expertise in machine learning came in. And how do we start to process what we're seeing up there in an efficient manner, so we can start to, the client never has to go to site. You know, these sort of operations can potentially be done without the roads ever closing. And they get a complete breakdown of all the faults that are happening on their asset. Not only that, can we give them a bird's eye view of what's happening on this road tunnel, so that they can now start to see these sort of features over time. So about 50 meters down that marker there is something that was happening, and this is what was happening in 2007 and in 2008. It got worse and it got worse, and they can mitigate and they can take actions based on that information. Next up, this is an exciting project that I'm really interested in right now. Is clients have come up to us and said, okay, you guys are robotics experts, and we have these remote tunnels that provide a lot of water to all the farms in different counties, and we have never been in those tunnels, and we want to do some construction work, but we have no idea if there's any obstacles, what the conditions are like instead, and we don't know how to budget the project either. So what we are building is an autonomous system, floating platform that can navigate itself through the tunnel. And the technologies being used there are very similar to what are used in autonomous cars. So get that robotic system to sense the world around it, be able to navigate itself through the obstacles, and at the same time collect at the bottom right these very dense and rich profiles, so that engineering firms can start to make better decisions about how to move forward with these assets. Lastly, back to the sort of pipelines that I was talking about earlier. There's thousands of kilometers of pipelines under many metropolitan cities, and there are days and days and days of continuous footage captured quite regularly in these pipelines, and literally they have people sitting and watching these videos, and that's all they do. And it's extremely laborious work where they're completely mind-numbing, and this is where we are looking at making an impact in automating that data processing. So someone else is collecting the data here. But now we're looking at how do we translate that problem into a machine learning problem, first of all. So that's one of the biggest challenges there. You know, how do you take original data that they have, which is typically garbage, and how do you make it work for your own needs? So how do we automatically start to detect these things and be able to provide solutions to the client so that the 20 people team that they have with a backlog of work can now actually do 10 times more work than they used to be able to do. As an efficiency tool. And the work has actually starts to become more interesting also. So the turnover of employees actually is also increasing. Lastly, what OS has been transitioning to over the last 12 months is the offshore sector, where the assets have very high risk associated with them, and there's high value to mitigate these risks. Now, I can't really show you some of our data there because of data privacy issues, but I'll take us back to that video from Robotics, which created this drone that can go out and inspect areas where people cannot go themselves and reduce the need for a person on board. And they go out there and collect a range of data. So in this case, point cloud data, a range of image data, and our aim right now, or what we have already sort of demonstrated to clients in Houston, is to be able to automatically assess the health of your entire rig so they can make better decisions on how to cater for them.